Hey everybody, this is Coach Hammock coming to you from beautiful Georgetown, Texas, here in room 122 at Benold Middle School at 5:08 p.m. on Saturday, November 16th. That's right, guys. I have nothing better to do on the weekends than to come up to school and work. I know. Just all for you guys. So anyway, we're going to be talking about Chapter 6, Section 4, Solving Compound Inequalities. If you want to follow along in your note-taking guide, that's what I'm going to be using here. Probably be a good idea to do that. And let's go ahead and get started. First off, what is a compound inequality? Consists of two separate inequalities joined by and, or. That's the main thing we're looking for. We have and statements and we have or statements. And statements are going to be the ones where it's joined together. The lines are joined up right here. Or statements are going to have an open space in the middle right there, and it's going to be going less than or greater than. Okay, that's the main difference. All right, so here we go. Let's jump right in. Translate the verbal phrase into an inequality, then graph the inequality. All real numbers that are greater than or equal to -2 and less than 2. So we have all real numbers, we're going to call that x, there it is, that are greater than or equal to -2. Well then, if x is greater than or equal to -2, then -2 is less than or equal to x. Okay? And then x has to be less than 2. So that's our equation right there. And you'll notice this is the and statement. So what we're going to do, we're going to start at -2. And let me get right here. I'm just going to go with this. And we're going to go from -2 to 2. So we're going to start right here and we're going to go to 2. Now that's not real big right there, but you're going to see what we're going to do here in just a second. Now look, we've got this or equal to. Or equal to means that the center is full. If it's just less than or greater than, then this side, the center is going to be empty, right like that. So that's what our line is going to look like for that example. Going on to example B. All real numbers are less than or equal to, sorry, let me get that a little bigger, that are less than or equal to 3 or greater than 6. Okay? So, less than or equal to 3 or greater than 6. So x is less than or equal to 3 or greater than 6. So that's our statement right there. And for this line, I'm going to have to change it right here, and I'm going to go with this guy right here. And so we're going to start at 3. Our variable's on the left. If our variable's on the left, it's going to point in the right direction. So we're going to start there, and it's going to go that way. And then we have x is greater than 6. So we're going to go right here to the 6, which for some reason is missing. We'll go ahead and just put that guy right there. All right, there's one thing I forgot to do. That's right. It's color a circle or leave that open. Okay, yes, I know I'm using yellow, but it just shows up real well on the red. So we have less than or equal to, filled in circle, greater than 6, open circle going that way. Now remember, what that means is it doesn't include 6, but it includes everything that's larger than that. All right, so example 3. All real numbers that are greater than -8 and less than or equal to -3. So let's see what we've got. All real numbers that are greater than. So -8 has to be less than x because x is greater than -8. And x is less than or equal to -3. So there we go. We're going to go here and we're thinking about what we probably need, and it's probably this right here since it's an and statement. We're going to go from -8 to -3 right there. Come up. We're looking up. This one is the or equal to, so I'm going to leave that filled in. This one is not. That's an open circle right there. All right, so let's increase the complexity a little bit here. Solve 15. Now, on the computer program where I pull these from, it doesn't like the less than or equal to, greater than or equal to, so I've got to write those in. Sorry about that. Solve 15 is less than or equal to 3x minus 3. is less than 24. Graph your solution. So what we're going to do, we're going to split this into two different inequalities. The first inequality is going to be 15 is less than or equal to 3x minus 3. And then our second one is 3x minus 3 is less than 24. First thing we're going to do to both of these is we're going to add positive 3 to each side. So that's going to be 18. This is going to be 27. So let's just work this side first. 18 is less than or equal to 3x. If we divide each expression by 3, this would be 6. And so we come over here, divide it by 3. This would be 9. The compound inequalities can be written as 6 is less than or equal to x is less than 9. The solutions are all real numbers. Basically, you can fill this out. Greater than 6. All right. So I'll just put greater than or equal to 6 and less than 9. So if we were going to graph it, we're going to go from 6 to 9. Right there, we're thinking, okay, I've got an equal sign or equal to. I don't have one there. This is the one that needs to be open, right like that. Okay, moving on. Solve. 15 is less than negative 7x plus 1 is less than 50. Graph your solution. And again, we have an and statement, so that's going to help us here. Now, if we rewrite this, we could split these apart, and that's totally cool. In this situation, the book actually didn't. It just wanted to show you another way of doing this. You're going to subtract 1 from each expression. So this would be 14 over here, and this would be 49. So 14 is less than negative 7x is less than 49. You're going to divide each expression by negative 7. Now, something should be going off in your mind about that. Oh, wait a second. If I divide by a negative, I have to flip the inequality. All right, so we have to flip the inequality right there. So if we divide by 7, this is going to be negative 2 is greater than x is greater than negative 7. So the solutions are all real numbers. I could leave it like this, but I like it pointing the other direction because it puts it in order. So negative 7 is less than x is less than negative 2. All right. So I kind of messed that up, but the solutions are all real numbers greater than negative 7 and less than negative 2. So if we go right here, negative 7, negative 2, we're looking, are there any that need to be empty or the circle not filled? Yeah, actually both of them. So undo that, we're good to go. All right, everybody see that? No equal signs, and so it's an open circle. All right, this time we have the or right there, an or statement. So we have 5x plus 6 is less than or equal to negative 9, or 2x minus 8 is greater than 12. Graph the solution. We write the inequalities. Basically, we're just solving these out. If I subtract 6, I have 5x is less than or equal to negative 15. We'll go ahead and solve this one. Divide by 5, divide by 5. X is less than or equal to negative 3. On this side over here, I'm going to add 8. 2x is greater than 20. Divide by 2, divide by 2. X is greater than 10. So the solution to this are all real numbers less than or equal to negative 3 or greater than 10. So when we graph this on the number line, we're just going to get this guy right here. We're going to start at negative 3 and we're going that way. X is less than or equal to negative 3 or x is greater than 10. So we're here going like that. I forgot to do one thing. You should see it right now, and it's going to be this guy right here. Needs to have an open circle right there, and I'm just trying to show you that that's an open circle. All right, moving on. Checkpoint. Solve the inequality. Graph your solution. Well, first thing you should see, this is an and statement. Negative 3 is less than or equal to negative 2x plus 1 and negative 2x plus 1 is less than 11. So when we're working this out, we're just going to solve it. And what I want you to do, try to solve this on your own. I'm going to pause it and come back with the answer. Alright guys, this is what I came up with on this problem. On this side over here, the first part of this equation right here, I came up with 2 is greater than or equal to x. Don't forget that since you're dividing by a negative 2, you have to flip that sign. And over here I came up with x is greater than negative 5. So if I took these and combined them into one equation, or one inequality, negative 5 is less than x is less than or equal to 2. And so you can see up here negative 5, all my x values are above negative 5. Alright, you know what? I actually messed up on that, and I put the wrong one filled in. So I'm going to go negative 5 to 2. Right like that. I'm going to come here, and then because there's no equal sign, the negative 5 is the one that is not filled in right there. Alright? Okay, so let's go to the next example. Again, same thing. There's your key right there. Or fill this out, solve it. I'll be right back. Alright guys, so this is what I came up with on this the second one. I have x is less than negative 2 or x is greater than 3. And both of them have open centers right there because they are not equal to those numbers as well. Alright, so that's about it for today's lesson. Don't forget about your whisk and have that ready for class on Monday. Hope you all have a great weekend, and we'll talk to you later. Bye.